GCSE revision video for June 18, Higher Unit 1, Question 10, having a look at some enlargement. So the first thing, before we get stuck into the question, the first thing we're just going to have a little look at some scale factors. Now on all of the diagrams that you're going to see, the blue is the object, so that's the starting shape if you like, and the red is the image, so the shape that has resulted from the enlargement. So let's have a look at a few scale factors and see if we can see what's going on. So remember, the blue is the original shape or the object, and the red is the image, so when it's been enlarged. And you can see in this shape, if I look between C and D, it was 1 unit and it's now 2 units. If I look vertically, it was 2 units, it's now 4 units. So I can see I've got a scale factor of 2. Everything has remained in proportion. These are similar shapes. All the sides are in the same ratio. So they've all been doubled. Let's have a look at the next pair. So with this one, we can see between C and D, I've still got, if you like, on the top of this trapezium, I've got side length 1 in the original, in the object, and 2 on the red version, and it's 2 high in the object, and it's 4 high in the original. So again, everything's been doubled, but we can see that this shape has, if you like, been turned upside down or rotated 180 degrees. And you can see the little dot that represents the centre of enlargement. And this one has in fact been enlarged by a scale factor -2. And the negative in there kind of showing you that it's been turned upside down. Next one, let's have a quick look. We can see it's got a height of 2 here, and across a little width there of 1 still. And now we've got a height of 6, and it's 3 across. So we can see that each side has been multiplied by a factor of 3. This one, if you count it through, have a little look, 1 to 4 and 2 to a height of 8. So we've got a scale factor of 4. And one last one to have a look at. We can see this is 1 and it's 2, and it's 1 and it's 2. So it's exactly the same size, but again, much like the scale factor -2, this shape has been flipped upside down. And so it's got a scale factor of -1. So bearing in mind positive scale factors, the shape, all the lengths will be doubled if it's a scale factor 2, or tripled, scale factor 3. But the shape stays the same way up. But if it's a scale factor -2 or -1, the shape still gets bigger if it's scale factor -2 or -3, but it becomes upside down somehow. We'll have a little look at why that happens in a second. Thinking about then, the next thing I want to look at is the centre of enlargement that we should be using when we're doing these shapes. The centre of enlargement, we're going to look at where 2 or more of the construction rays join together. So if we draw those on, so if I take my first shape over here, and I draw a construction ray through the corresponding vertex, so the corresponding corners of these shapes, and I'm just going to draw it through 2 corners. I could draw it through all of them, but I'm just trying to keep my drawings nice and simple. I can see the centre of enlargement where these 2 construction rays meet is at the point -1, 4. So these construction rays going through corresponding corners or vertices where they meet. I'll have a look now here. Again, same thing through the bottom and acute angle on this trapezium. I can see the centre of enlargement is going to be at the point 2, 9. And again, with this one, the same process, still drawing my rays through the corresponding corners, vertices, and it's where they meet. And on this one, they actually meet inside the shape, which is quite unusual, but is possible. And so we have a centre of enlargement at 8, 4. So 2 things we need to remember when we're doing these enlargements. We must have a centre. Okay, let's have a look at this video, which is going to show us the enlargement we need to do for this question. And a little bit extra, and then we'll do it properly with pen, pencil and ruler, see where we're going. So the first thing I need to do is I need to have some construction rays. I need to draw those through the centre of enlargement through each vertex of my shape. So through A and through B, and I draw them as far as I can, probably use the whole grid that you're given in the exam, stretch as far as you can, and actually I'm going to draw the third one in as well, so you can see how these vertices move. So each corner of that shape will slide along the corresponding ray. If I set it to a scale factor 2, the shape has become twice as wide, twice as tall. Scale factor 3, 3 times as wide, 3 times as tall, and it slid along those rays to where it fits with that twice the size or 3 times the size. If you make it a scale factor half, shrinks down, so it's half as wide, half as tall. Scale factor 0, it disappears. And if we make the scale factor negative half is half as big, half as wide, but it's the wrong way up. Minus 1, it's the same size, upside down. And minus 2, twice as wide, twice as tall, and upside down. Okay, so let's enlarge the triangle by scale factor minus 2. So I'm expecting it to double in size, but be turned upside down because of the negative. I'm using the origin as the scale factor. So I've got my origin marked, and I'm going to draw a construction ray through each one of my vertices as neatly as I can, and I make sure that they stay there so the examiner can see them. Really important that they're still on your drawing when you finish, so don't be rubbing them out, leave them in nice and clearly. I'm going to look at the position of this first vertex, okay, so I can see that it's 1 across and it's 2 up, and if I multiply that by the scale factor of minus 2, 1 times minus 2 is minus 2, and 2 times 2 is minus 2 is minus 4. And I know I need to be going backwards, and that agrees with what I just talked about. I'm going to go backwards 2 and down 4. So my new vertex, this one, is going to be at the coordinates minus 2, minus 4. And I can see it's travelled along that ray. So that green corner there is travelled along and is down here. Now I'm going to have a little look at the bottom right, which is 3 across, and it's 2 up. Times that by minus 2, I need to go backwards or do negative 6 to the left and then 4 down, and I can see that corner has travelled along that ray, that vertex travelled along that ray, and it's going to be plonked there. Now that's given me enough to draw my shape, because I know it was 2 wide and it's now 4 wide, but I know it's going to be upside down, so instead of being 1 high, it's now going to be 2 high, but it's going down instead of going up, if you like. So I can squeeze or draw in accurately my triangle just there. So if I have a little double check, it was 2 wide and 1 high. Now it's 4 wide and 2 high, but if you like, this is upside down, so it's 2 down and 4 to the left. Finished. So that exam question was quite straightforward, but there are other things that might be added onto the end of an exam question about transformations, and scale factors and exploring height and area and possibly volume are worth having a look at as well. So we're going to do a little mini investigation really quickly, and we're going to look at what happens when we examine scale factor 0, 1, 2, 3, 4 for this little rectangle here. And we're going to look at what happens to the height of this rectangle and its area as we apply different scale factors. So you can see what I've got drawn here. My blue is my original shape, and it is 1 wide and it is 2 high. So the height of this original rectangle is 2, and 2 times 1, I know its area of this original shape is 2 as well. If I look for then a scale factor for a scale factor 2, and I look at the height when it's a scale factor 2, it's got a height of 4, and the area is 2 times 4, so it's got an area of 8. So let's carry on this exploration a little bit further. If I now do the enlargement at scale factor 3, height is 2, 4, 6 units high, and the area 3 times 6 gives me 18. If I have a look at scale factor 4, probably figured it out, 2, 4, 6, it is going to be 8 high, and 4 times 8 for the area is 32. What's the scale factor when it's 0? Well, the shape will disappear, it will have no height, and it will have no area. So are there any patterns we could pick out? If it was a scale factor k, what could we say about the height? What could we say about the area? So we might have spotted, in fact, this is the 2 times table. So the original height is 2, and it's just been times by 1, 2, 3, 4, or 0, which is the scale factor. So the height is 2 lots of the scale factor in this particular shape, and the area is being times by 0, for a 0 scale factor, 1 when the scale factor was 1, 4 when the scale factor was 2, 9 when the scale factor was 3, and 16 when the scale factor was 4. So this is 1 squared, 2 squared, 3 squared, 4 squared. So the area is being times by k squared. So whatever the original height was, its new height is just times by the scale factor. Whatever the original area was, it's just being times by the scale factor squared. So because we had a height of 2 to start with, we've just times it by k. Because we had an area of 2 to start with, times it by k squared. So if the height is multiplied by a scale factor of k, what that means is the area will be multiplied by a scale factor of k squared. So what happens if it's 3D? What happens if we've got volume? Do we have the same kind of thing happen with our scale factors? Well, the length scale factor is k, so all of these sides will have just been multiplied by k. The area, so in this case it could be the area of one of the faces of this 3D shape, or it could be the total surface area of this shape, will have been multiplied by k squared. But the volume, as you enlarge this shape by certain scale factors, well, you might have guessed it, it will be k cubed. And you could do a little investigation with some shapes to see if you can spot that. So that's it for this video. Hope that helped. Thanks.